How electrical transformers work. Electrical transformers are one of the reasons modern electrical grids actually function efficiently. Without transformers, long-distance power transmission would become dramatically less practical. Entire electrical systems depend on these devices quietly adjusting voltage levels constantly across the grid. And despite the name, transformers do not secretly turn into robots during maintenance operations. Which honestly feels like a missed engineering opportunity. So today we are going to walk through how electrical transformers actually work and how they move electricity across modern power systems. Transformers change electrical voltage levels. They can increase voltage or reduce voltage depending on the application. This helps electricity travel efficiently through transmission and distribution systems. Transformers operate using electromagnetic induction. Alternating current flowing through one coil creates a changing magnetic field. That magnetic field induces voltage inside another nearby coil. The two coils remain electrically separate. Energy transfers magnetically between them. Most transformers contain two main windings. The primary winding receives incoming electricity. The secondary winding outputs electricity at a different voltage. The ratio between the number of wire turns determines how voltage changes. More turns on the secondary winding increase voltage. Fewer turns reduce voltage. Power plants usually generate electricity at relatively moderate voltages. Transformers immediately increase that voltage for transmission. High voltage transmission reduces energy losses across long distances. This is why power lines often operate at extremely high voltages. Electricity may travel hundreds of kilometers efficiently before reaching cities. Substations then use additional transformers to reduce voltage gradually. Neighborhood transformers lower voltage further for homes and businesses. By the time electricity reaches household outlets, the voltage becomes much safer and more usable. Transformers only work with alternating current. Direct current does not create continuously changing magnetic fields in the same way. This became one major reason alternating current systems dominated early electrical grids historically. Transformers generate heat during operation. Large transformers often use oil cooling systems. The oil helps remove heat from internal windings and cores. Some extremely large transformers contain elaborate cooling equipment, which means certain electrical boxes quietly contain more engineering complexity than many entire household appliances. Transformer cores are usually made from laminated steel. The core helps guide magnetic fields efficiently. Laminations reduce energy losses caused by eddy currents. Efficiency matters heavily because transformers operate continuously across the grid. Modern transformers often exceed 98% efficiency. Large electrical substations contain many transformers simultaneously. Substations route and control electricity across power networks. Transformers allow electricity to move between transmission and distribution systems smoothly. Transformers also help isolate electrical systems safely. Different voltage regions remain separated while still transferring energy efficiently. Protective systems monitor transformer health continuously. Temperature sensors, oil analysis systems, and electrical monitoring equipment help detect failures early. Large transformer failures can seriously affect power grids. Reliability remains critically important. Renewable energy systems also depend heavily on transformers. Wind farms and solar farms use transformers before feeding electricity into the grid. Electric vehicles, charging infrastructure, factories, and data centers all rely on voltage conversion systems constantly. Transformers became one of the quiet foundational technologies supporting modern electrical civilization. Most people rarely notice them despite seeing them almost everywhere. Neighborhood poles. Electrical substations. Industrial facilities. Power plants. Transformers quietly manage voltage changes continuously behind the scenes. To wrap up, electrical transformers work by using electromagnetic induction between primary and secondary coils to increase or decrease alternating current voltage levels efficiently. Transformers help power grids transmit electricity over long distances while reducing energy losses significantly. Cooling systems, steel cores, substations, and protective monitoring systems support reliable transformer operation continuously. Modern electrical grids depend heavily on transformers to distribute safe and efficient electricity across homes, cities, industries, and renewable energy systems. This has been a mini Leviathan production. If you enjoyed it, check out our other videos. See you in the next one.